dragging all day today, so I kind of get the sense y'all are kind of out of it today, so I don't know. You okay?
Okay.
All right. Hey, by the way, in a few days, hopefully, probably next week, we're going to be doing something, trying something a little bit different. I'm going to have a tablet PC that I'm going to write on, and it's going to project. And so instead of me sitting here and writing and talking, I'm actually going to be like, all right, so, you know, what do y'all think of this problem over here? And I'm going to be writing here, it's going to be appearing up here, and I'm going to have like a wireless transmitter that's going to go to the projector. So I'm going to be more like coming around here like this. And I'm going to want to see what kind of, like if y'all like that compared to this. You know what I'm saying? So, because I don't mind doing this, but it's the lugging it around everywhere that's just kind of a pain in the butt for me. So.
What if I'm like, well, what about right there, and then you want to point it out? Can you point it out on your tablet? You just walk over.
What do you mean? Like if you want to point something out?
Yeah.
Yeah, I'll have a stylus and I'm going to be writing, and as I write, it's going to be showing up on the projector.
Oh.
But I'm going to be recording the screen at the same time. So it'll be recording also, so I'll be able to put that on the web. And it'll be much better resolution, and it'll be very, very clear. And so it's coming down the pipe, hopefully in a couple of days. What do you think here?
Secant x, that's your u. Secant squared.
Secant squared times secant. Okay, let's do that first. Let's look at this integral as secant squared x times secant x. Good. And now, picking a u and a dv, we might be kind of, well, which one is there an obvious choice of dv or an obvious choice of u here? Secant squared is the derivative of something, isn't it? Of tangent, isn't it? So I could let the dv be secant squared x dx, and then I could let the v be the antiderivative of that, which would be tangent x. But that forces me to choose my u to be whatever else was there, which is secant x. What's the derivative of secant x? Secant x tangent x, right? dx. Are you with me? Now what? Ultraviolet minus voodoo. So this becomes, ultraviolet is secant x tangent x minus voodoo. What's voodoo? Tan x times that, right? Tan x times that. So can't I do secant x tan squared x dx? Is that all right? Now watch what I'm going to do here. I'm going to take the tangent squared x, and I'm going to use a Pythagorean identity. Remember the Pythagorean identities? They're like sine squared x plus cosine squared x equals 1. And there was another one, 1 plus tangent squared x equals secant squared x. And that one, I can solve for tangent squared x, so I get secant squared x minus 1. And you have the formulas, and you know, if you brought that. So this should become secant squared x minus 1. That's tangent squared x, right? And then when I distribute the secant through, right, I'm going to get a secant cubed again, aren't I? So my secant cubed that I'm trying to find is about to appear on the other side. Yes? And then I'll have another integral with secant. But I know the antiderivative of secant because it's on your formula sheet. So here's where we are. The original integral, secant cubed x dx, is equal to ultraviolet secant x tangent x minus integral secant cubed x dx plus integral secant x dx. So where did the plus come from?
Minus, minus.
Minus, minus, right? This secant x comes through, becomes a negative secant x, but then I'm subtracting the integral, so it becomes plus. So I've got that. What am I going to do with this integral? Add it to both sides, right? And then what am I going to do with this integral? Use the formula sheet, right? Use your formula sheet. So when I add this to both sides and add it over here, how many of them do I have? 2 of them, right? I didn't have any fractions to deal with. So I have this integral plus itself. So I have 2 of those secant cubed x dx's equals secant x tangent x, and then plus, what was the antiderivative of this on your formula sheet? I'm going off of memory here. I don't think.
Natural log.
Is this it?
Yes.
Is that it, really? Oh, okay. Good. So this is just a formula. Am I done though? Yeah, divide everything by 2. So I would actually, instead of dividing by 2, I'd put a 1/2 in front here and a 1/2 in front there and get rid of that 2, and I'm done. So this is the antiderivative of secant cubed. Questions? With that in mind, let's look at our first, what we call reduction formula. All right, so reduction formula. So let me put this up on the board first and then we'll go about showing it. It turns out that the integral of secant to the nx dx is equal to tangent x times secant to the n minus 2 of x all over n minus 1 plus n minus 2 over n minus 1 integral secant to the n minus 2x dx for n not equal to 1. This is a formula basically, and it gives you a way. I'm going to wait for everyone to have it kind of jotted down. This formula gives us a way to reduce the power on a secant in an integral. So if I have secant to the n power, it becomes this, and then secant to the what? N minus 2, right? So see how I've taken the secant power in this integral and reduced it? Yes? What we need to do right now is generate this formula. All right? We want to show that this is true. You ready? This is by far the hardest problem you're going to see on the test, is something like this. All right? Because it's general. There's no numbers like, this is a general formula that you are going to create. You ready to see it? So I got to show this at the end of the day, that this is true. Let's just check it real quick. Let's see that this formula works. According to this, what's the antiderivative of secant cubed x? According to this formula, that means n is 3, isn't it? So that should be equal to what? Tangent x secant of what? 3 minus 2 is 1, so secant to the first power x over n minus 1. What's n for us? 3, so 2 here, plus, what's n minus 2? 1 over 2 integral of secant to the first power x dx, right? And what's the antiderivative of secant x dx? That's our formula. It's natural log of all that, right? Natural log of secant x plus tangent x, and put a half in front of it. And isn't that what we just got in the previous problem? So you see this formula does work for cubed. We need to show it works for n. So isn't having a formula like this much more powerful than having to do each one of these? Like if I did secant to the 5th now. Instead of going through all that work, you could turn a secant to the 5th into all this stuff secant cubed, right? And then you can turn that secant cubed into something secant. And so each one gets, you can reduce with the formula over and over. Does that make sense or no? All right, let's go for this. Remember, keep the eye on the prize. That's where we're headed. All right. This will most likely be our last problem of the day. All right, so I'm going to go integration by parts just like we did before. But before, we took the secant cubed and we split it up into secant and secant squared, didn't we? Secant and secant squared? So I'm going to have to do this first. I'm going to have to rewrite this as secant to the n minus 2x times secant squared x. Does everyone understand what I've done there? It's like kind of me writing x to the n is equal to x to the n minus 2 times x to the 2. When you have the same base, what do you do with the exponents if you're multiplying the two bases together? You add the exponents, right? So what's n minus 2 plus 2? N. Right? So I've taken secant to the n, something to the n power, and rewritten it as something to the n minus 2 times that something to the 2. So that when you put these back together, you get this, don't you? So I have squeezed a secant squared out of that, haven't I? The reason why, any questions? This is a critical step there. The reason I did that is so I can set up a dv to be secant squared x. Why? Because the antiderivative of that is tangent x, right? So tangent x. Okay, u then has no choice but to be what? Secant to the n minus 2x, right? So this has got to be secant to the n minus 2x. And now I need du. Now you have to be real careful here. Before I get that, what if I had secant to the 7th x here? What would the derivative of that be? Chain rule. Careful, chain rule. What would the derivative of something to a power be? 7 secant x to the 6th, right? So it'd be power, chain rule says you take derivative of something that's there, 7 comes out, all of that to the 6th, right? Then go inside and take derivative of what's inside. What's the derivative of what's inside? What's the derivative of secant x? Secant x tangent x, okay? So I'd then have next to this secant x tangent x. That's how I would do secant to the 7th. I don't have secant to the 7th, I have secant to the n minus 2. So what's going to come out in front? N minus, I'm going to have to write it down here because I'm going to run out of room. I have n minus 2 came out in front, secant to the n minus, careful, we're taking a power away. We're subtracting a power. So n minus 3, right, x times, now derivative of secant. So secant x tangent x. dx. Is that all right? Okay. So let's see where we are here. This integral right here becomes ultraviolet tangent x secant to what power? n minus 2x minus integral of tangent x times this, right? Right? By the way, what about this secant to the n minus 3 times the secant? Isn't this like secant to the first power? So couldn't you multiply these together, add the exponents, and get what? n minus 2, right? So my new integral here is going to become the n minus 2 right here. Secant, how many? To the n minus 2x times how many tangents? Oh, I forgot my x here. Right there. Tangent x times tangent x is tangent squared x dx, isn't it? This equals tangent x secant to the n minus 2x. What are we doing? Minus integral n minus 2 secant to the n minus 2x times, what did we do in the last problem with that tangent squared? We turned it into secant squared x minus 1 dx. Turn this into this right here. Let's pull that n minus 2 out of the integral, okay? Let's get that out of there. So here's where we are. We've got the tangent x secant n minus 2x minus the n minus 2 is a constant coming out, integral. What happens when you do secant to the n minus 2 times secant squared? You get secant to the what? N. Good. Secant to the nx, and then when you do that times that, don't you get a minus secant to the n minus 1? Or sorry, n minus 2? Minus secant to the n minus 2x, and then dx. Now, secant to the n is what we're trying to figure out, isn't it? So can't I somehow get that and move it to the other side of the equation?
Yes.
And then this right here, well, we'll see what it is. Is Jack on the bottom of the ocean right now, or what? Y'all okay? Okay. Any questions on that? I just took this negative right here. I made this go to here and had one integral here. Then the negative and the negative became positive and minus 2, and then we have a new integral right here. So I just split this into two integrals. Now this is all equal to the left side of the equation. What's the left side of the equation over here? Secant to the nx dx, right? So how many, this is where things get real weird, okay? Kind of. It's already weird, but if I have that many of those over here, I'm going to get rid of it over here. What am I going to do? Add that many, right? So how many do I have over here? N minus 2 of them, right? So I need to add n minus 2 of them over here. So I'm going to add n minus 2 integral secant to the nx dx. That means add over here n minus 2 integral secant to the nx dx. And what happens to these? They're gone. How many of them do I have over here? That's one of them, right? So if this was, let's say, well, you tell me. What is this? What's n minus 2 plus 1? N minus 1, right? N minus 2 is a number. Add 1 to it is the same as n minus 1. So we have over here n minus 1 of these integrals equals what's still over here? Tangent x secant n minus 2x. This integral was gone, plus n minus 2 integral secant n minus 2x dx. And what would be the last thing you do? Get rid of this n minus 1 by dividing through by n minus 1, right? If I divide this by n minus 1, it's gone. If I divide this term by n minus 1, I get an n minus 1 here, don't I? And if I divide this by n minus 1, I get an n minus 1 over here. Isn't that the reduction formula? Go back and look at what I was trying to show. I was trying to show that this was equal to tangent x secant to the n minus 2 over of x over n minus 1 plus n minus 2 over n minus 1 integral secant n minus 2x dx. Wow, right? So here's what I would suggest for homework. I already had you do through 9, right? So you should do 11 through, this is page 316, 11 through 29 odd. 31, 33 are kind of optional. They wouldn't hurt. 35 and 37. Those are both reduction formula problems. And I'm going to offer as a bonus to be turned in next class, beginning of class, number 36. Okay, number 36. And turn it in at the beginning of next class on separate paper. Don't put it on with your other homework. All right? That's a reduction formula problem. 35 and 37 are reduction formula problems. So what are we going to do next class?
Go over 36.
Review?
Yeah, but what do y'all want to do for review? I mean, I can sit here, I mean, I'm just doing problem after problem after problem. What you probably know by now is that you have to do these problems to get good at them, right? So what is it that you want to see for a review? More of me doing the same stuff up here, or?
A little bit of each, like segmented.
Like what?
Always the more difficult one to be. Because we can realize it's
Like
As difficult as it's
substitution,
going to be on the test.
substitution, difficult.
See, the problem with difficult is that the problem is going to be easy if you see the substitution, right? Like if I give you a substitution problem and you see the substitution, it's going to come out nice. If you don't see it, it's going to be hard. So it's difficult for me to gauge like what's hard and what's easy. I mean, I can kind of gauge it, but I might give a problem. Like the problem I gave today for the quiz. To me, that was easy. That was an easy problem. But if you sat there and you looked at it and looked at it and looked at it and looked at it and it didn't come, then it was hard, right? I mean, that's the way this stuff works. So, okay, so you want to see me do more problems? Just a mix of problems? You'd rather me come in here with some problems, hand them to you, and let y'all work on them and answer questions? Okay. We can do that. All right.
It's going to be a substitution and integration by parts?
Yeah. But then we have everything else that we've covered.
Yeah, I don't remember.
Riemann sums, and
That stuff.
but that stuff at this point probably seems pretty trivial, right? I mean, unless I ask you to actually compute a sum, but I don't think I will. That's just tedious work.
Yeah.
But I also plan on there being maybe some, some sort of like not word problems, but like some theory problems, like, what does the integral, that definite integral a to b represent? Geometrically, what is it? What does the f of x dx look like, when you connect it to Riemann sums? What is it? What is it? The area of the little rectangle, right? The width of the rectangle times height. That sort of thing too. I don't want this to be just purely mechanical. Well, what I'm not going to do is come in here and just hand you a review and say, just if you do these problems, you're good. Because really, this is probably the only review you're going to get like this semester. Next test, you won't have one. Only because you just don't normally in a math class get a big review at this level. It's kind of like if you've done your homework, that's your review. You want to review for the test, go back and look at your homework. That's what you should be studying. But I'll try and at least give you that one day next class to sit down, me hand you a piece of paper and say, show me the money, and see if you can do it, and be able to ask questions. Just that one time. How do y'all feel? Y'all feel ready or not yet? We'll see, right? Okay, be here next time. When is it? A week from today? The 18th? Let's see, we took a quiz. I'll do it based on, did everyone turn in something for the quiz? As long as you turn in something for the quiz, you'll be counted present today. Okay. Just write your name on a piece of paper and turn it in so I can take attendance off that.